When an aircraft departs from level flight, the static pressure changes. The vertical speed indicator measures the pressure difference between each side of a metering unit. In level flight, the pressures on each side of the metering unit are the same. During a climb or descent, air fed to the capsule immediately responds to the change of atmospheric pressure, but the metering unit transmits this change at a lower rate. Static pressure is fed to a capsule enclosed within an airtight case. The case itself is also fed with static pressure, but this feed comes through a restricted metering unit. Thus, if the static pressure is changed, the pressure surrounding the capsule changes at a slower rate than that within the capsule. If the aircraft is climbing, the pressure in the capsule will be less than that in the case. The consequent compression of the capsule is converted by a suitable linkage to a pointer indication of the rate of climb. If the aircraft is descending, the pressure in the case will be less than the pressure in the capsule, causing the capsule to expand, which will move the linkage to indicate the rate of descent. Two types of presentation are available: a linear scale and a logarithmic scale. It will be obvious from comparing these two diagrams that the presentation of a logarithmic scale is easier to read at the lower rates of climb and descent. Select any of the four buttons to learn more about the main errors that occur within the vertical speed indicator and its associated equipment. Instrument error is due to manufacturing imperfections. If the static pressure is subject to position error, the vertical speed indicator will wrongly indicate a climb or descent when speed is suddenly changed. This is most noticeable during takeoff acceleration. Any short-term fluctuations in pressure at the static vent during attitude changes will cause the instrument to indicate a false rate of climb or descent. Additionally, most vertical speed indicators have a small counterbalance weight included in the linkage, the inertia of which causes delays in the indications of changes in vertical speed during maneuvers. The vertical speed indicator pointer takes a few seconds to steady because of the time taken to build up a steady pressure difference on climb or descent. There will also be a time lag on leveling out because of the time taken for the pressures to equalize. This error is most noticeable after a prolonged climb or descent, especially at high rate. To overcome the problem of lag, the instantaneous vertical speed indicator incorporates an accelerometer unit which responds quickly to a change of altitude. Select either descent or climb to see what happens in the instrument. The piston in the vertical acceleration pump immediately falls in the cylinder and decreases the pressure in the capsule. The capsule contracts, and the pointer will give an instant indication of climb. If the vertical acceleration ceases, after a few seconds the piston will slowly rise to its original position. But by this time the correct differential pressure between the capsule and the case will have been set up, and the correct rate of climb will continue to be shown. The piston in the vertical acceleration pump immediately rises in the cylinder and increases the pressure in the capsule. The capsule expands and the pointer will give an instant indication of descent. If the vertical acceleration ceases, after a few seconds the piston will slowly descend to its original position. But by this time the correct differential pressure between the capsule and the case will have been set up, and the correct rate of descent will continue to be shown. Any blockages of the static line or vent will cause the needle to return to zero. If the supply of air to the vertical speed indicator is blocked, it's probable that the other pressure instruments, the airspeed indicator and the altimeter, will also be affected. The following checks of the vertical speed indicator should be made before flight. The instrument dial glass must be clean and undamaged, and the instrument should read 0. In flight, the accuracy of the instrument may be checked against the altimeter and a stopwatch during a steady climb or descent, and the instrument should indicate 0 climb or descent when in level flight.